Okay, for this next problem, we have here a T-beam. So all of the parameters or dimensions are given, like the thickness, and then the span of the beam, and then the slab spacing 2.4 on centers. So the width of the web is 300 millimeters and a total depth of 550 millimeters. So assuming a steel covering of 65 millimeters. So here we have the distributed live load. We have here a moment live load and a moment dead load, while parameters for concrete and steel are also given. So the first unknown is to determine the effective width of the flange, and then the depth of the compression block, and then the required steel area of the beam. Of course, we need to refer to our code in order to solve for the effective width of the flange. Okay, for letter A, we have this criteria. First, L over 4, that is 6,500 divided by 4 will give us 1,625 millimeters. For the next criteria, we have 16 times thickness of 100 plus the width of the web, which will give us 1,900 millimeters. So the next criteria is S1 over 2 plus S2 over 2 plus width thickness. So in this case, we have a center to center spacing of the beam, which implied this equation actually, because we have just equal S1 and S2. So therefore, we just have to adapt the spacing itself, 2400 millimeter. And as we can see from the three criteria, we shall adopt the least, which is 1625 millimeters. Hence gives us the width of the flange, the effective width of the flange. Now for letter B, we have the depth of compression block, which refers to the variable A. So that should depend, the area of concrete or the depth of compression block should be depending on the capacity of the thickness or the thickness of the flange. Let's say we have here our T-beam. So of course, this flange area will have its corresponding moment capacity. Let's say that would be the initial capacity of the flange. We label it as mu1, and then mu1 shall be now compared to the requirement of the moment, which can be calculated from this one. Of course, the factored moment will just equal to 1.2 dead load plus 1.6 live load. So we substitute, and mu shall be yielded to 396.30 kilonewton meter. So our next step is, of course, to calculate mu1, setting that the compression block here is the area of the flange. So that block is equal to 0.85 FC prime times the flange area. Well, the distance here would be equal to the depth minus thickness all over 2. Hence, we're gonna place it in here and then substitute. Okay, for the flange area, we have 1625 by 100, and then the depth is the overall depth minus the clear cover, which is 65 millimeters, then minus thickness over 2, 100 over 2, that is equal to 50 millimeters. So here we can calculate mu1, which represents the moment capacity of the flange block here, hence giving us 1119.37 times 10 to the 6 Newton millimeters, which is greater than the required mu, which is 396.3 times 10 to the 6 Newton millimeter. So therefore, our block does not need to be extended after the thickness. So therefore, the depth of the compression block is somewhere lower than the thickness of 100 millimeters. So therefore, we compute it as we have been doing in a rectangular singly reinforced beam, whereas M is equal to phi times C times D minus A over 2. We have 0.9 times FC prime, 0.85 FC prime AB. So we adapt the flange width since it is within this zone times the depth of 485 mm, which is 550 minus 65, minus A over 2. So we place in here the moment, which is 396.3 times 10 to the 6th. We simplify the equation and then we will be dealing with a quadratic equation in here. So we have here the two roots, of course. We have here as correct root of A to be adopted here. Hence, answering the requirement for letter B. Now for letter C, we need, of course, the value of the location of the neutral axis, which is C. C is equal to A all over beta 1. Hence would give us 38.66. So we would like to show you that Fs is far greater because we have a small value for C. So we substitute. Then we arrive to a far great value than that of Fy. Hence, we satisfy that Fs is equal to Fy, or still yields. Now moving on for letter C. We just have to stick to this formula similar to the singly reinforced rectangular beam. So in here, AS is unknown, so we're going to adapt the formula of mu with that of in terms of AS. We substitute. So unknown is AS in here. Of course, Fy is adapted. 413.7 as given times D minus A over 2. So by manipulation, we can get AS equal to 2271.55 square millimeter. So that concludes problem number 5.